Okay, so today we'll be talking about socially relevant modeling, and I have outlined 5 steps that I think are necessary. They are interconnected, but also distinct. So first question we have to ask is, what are the relevant questions in socially relevant modeling? And that, of course, would depend on what we think are socially relevant questions. But we all have some idea, and probably ideas in the plural. And today I will present some examples of what I think are some of the socially relevant questions for modeling. Then the next question after that would be, what are the relevant theories and models? Theories are a little bit different from models. Models we all know from our experience with them in the field of social sciences. They are mathematically expressed relationships, usually in the form of equations and inequalities. But theories can be couched in non-mathematical terms, just verbal terms. In that way, they look less precise to people who are mathematically trained, but people who have strong verbal training in analytical subjects like philosophy can distinguish between more precise and rigorous ordinary language theories and the less precise or vague kind of expressions of theories in ordinary language. But ordinary language theories can also be quite precise and quite rigorous. But if we want to estimate things mathematically, we have to write down some kind of functional form for our equations, define our variables, the dependent variables as well as independent variables, depending on the questions that we are trying to ask and answer. Then, having gotten through this step, the first 2 steps, we have to ask, what are the relevant data for the exercise or exercises that we are about to undertake? And that question can be answered in light of the theories or models that we choose, because each theory, each model will have a set of variables that are relevant. But it is not as straightforward as that, as you know from your own experience in collecting data. To make an exact correspondence between theory and data is possible only under certain circumstances, and we are not always so lucky in social sciences. We cannot have laboratory experiments. We cannot tweak our variables in the way that we want, although there are social experiments and economic experiments, but they are not in the same category as controlled laboratory experiments in physics or chemistry or biology even. So we do have a very important step here. A lot of imagination and practical common sense are both necessary for getting through this step. Then we come to the 4th step, which is about techniques. So what are the techniques and how to use them? Not just a catalog of techniques, but also a practical proficiency with the use of techniques. And they range from knowing enough about statistics and econometrics in terms of theory of statistics and econometrics to the nitty-gritties of data sources and inconsistencies of data, and finally how to manipulate them by using specific softwares, or in many cases how to write the codes so that you can manipulate them in the way that the model tells you to manipulate them. So these are all very tall order items. But that's not the end of it either, because after we are done with all these steps, then we have to interpret what we have found. And then we have to go back to our first question about socially relevant modeling. That is, what are the policy implications? Right? How relevant something is quite often is intimately linked with how policy relevant it is. is it going to matter for someone or some group for some time at least? So these are the broad and general ways that we pose these questions. Let me quickly read you something from a kind of handbook of doing research in political science about quality of theory. This section begins with the question, what is a good theory? And according to this author, 7 prime attributes govern a theory's quality. First of all, a good theory has large explanatory power. Large explanatory power. The theory's independent variable has a large effect on a wide range of phenomena under a wide range of conditions. And there are 3 characteristics that one has to keep in mind. I will just mention them without elaboration. First is importance. Second is explanatory range. And third is applicability. But they all should make some intuitive sense, all 3 of them. Importance, explanatory range, applicability. The second characteristic of a good theory or good theories should be that they elucidate by simplifying. They elucidate by simplifying. Hence, a good theory is parsimonious. It uses few variables simply arranged to explain its effects. But we will see that this is not always true. Because social phenomena are often very complex, our models really cannot be the simplest kind of models. Although, as a kind of heuristic, we should start with the simplest possible model and then ask, is it really adequate? Is it enough? And most often the answer will be no, and then we'll move. For example, we may start with a bivariate relationship, as we did in some examples, but then we move to multivariate analysis. But even that may not be enough. Third characteristic of a good theory is a good theory is satisfying. But what is satisfying? It satisfies our curiosity. A theory is unsatisfying if it leaves us wondering what causes the cause proposed by the theory. This happens when theories point to familiar causes whose causes, in turn, are a mystery. A politician once explained her election loss. I didn't get enough votes. Of course, that's true, but it's not satisfying to a political scientist, that is. We still want to know why she didn't get enough votes. Fourthly, a good theory is clearly framed. Clearly framed. Otherwise, we cannot infer predictions from it, test it, or apply it to concrete situations. One could say a lot more about this clearly framed criterion, but I will go on to the next item. The 5th characteristic is a good theory is in principle falsifiable. Data that would falsify the theory can be defined, although it may not now be available. But it's not as simple as that. There are actually very important debates in philosophy of science about this falsifiability. I won't go into that right now. 6th item on our agenda, and we are coming to an end. A good theory explains important phenomena. It answers questions that matter to the wider world, or it helps others answer such questions. Theories that answer unasked questions are less useful than if they answer these questions well. And then we can say, parenthetically, that much social science theorizing has little real-world relevance and thus fails this test. And I hope that what I'm about to show you today will be socially relevant modeling, and therefore they will not fall under this category of not having real-world relevance. Finally, a good theory has prescriptive richness. It yields useful policy recommendations. And that's the 5th point here, or half of it right there. OK, now you know what a good theory is or what it should be doing. So it's time to get busy. What I'm going to talk about technically is using something called let's see where to put it. Okay, we are going to ask what kind of CGE models, that is computable general equilibrium models, we can use for policy analysis. The abbreviation SAM stands for Social Accounting Matrix. And I will have more to say about that in context. So I'll be describing some approaches, I'll be giving some concrete examples, and I'll be giving especially one particular policy relevant example, which has to do with the relationship between trade policy and income distribution and poverty. But it can be used for many different purposes. But before I begin to all that, let me talk a little bit about modeling in general, because I think it's useful to know these basics. So here, which I have taken from another source, I'm not the original author here, we have really, at the end, a decision maker. At the very bottom, we have the decision maker. So this decision maker may be a very powerful person, like the President of the United States or the Secretary General of the United Nations. But these people are always too busy to really know the techniques or technicalities or even care for them. But they do want good information. And how do you then produce good information for them? How do you present it, of course, is another question, which is very important, but we are not going to deal with that during this session. But at the other end, we have the researcher, people like us, who are trying to produce that information. So we have a system, whatever system it is, in this case, a social system. A subsystem of that would be an economic system. Political system would be another subsystem. Then we have something called a domain expert, which would be people like us who have been trained to think about these issues in a systematic and scientific way. And each expert, or even groups of experts, may have a mental model of the system. And then sometimes it's the same person, sometimes they may be two different people or two different groups. There is another agent, we call this agent developer. So it could be that a professor, for example, comes up with ideas and creates a model. And then there are a group of people who will be developing those ideas and putting them in the form of a computerized model and cranking out all kinds of results. And the developer also will have a mental model of the system. The reason that there are two different colors is that they may not be the same mental model of the system. Although if it is the same person, they should be, they ought to be, and they had better be the same model. So you need dialogue, you need communication if there are two different groups or two different people. And then you come up with this computer model, which needs to be validated, which needs to be verified. But you have to then go to the user policy analyst, who may have some knowledge of these things, but not a detailed enough knowledge to really be able to develop the model and to implement the model and crank out all kinds of results from the model. But this user policy analyst is also a very crucial part of this whole apparatus, because without such a person, you will never have the information produced in such a form that the final decision maker can understand it. But of course, this user policy analyst will also have another mental model of the system. And therefore, you'll need more dialogue, at least between the developer and the user policy analyst. And finally, the decision maker herself may have another mental model. And so you need a dialogue. And especially at this stage, being able to translate technical language into a vocabulary that doesn't distort too much, although it does distort a bit. Nothing is free. But without distorting things too much, the policy analyst should be able to communicate clearly with the decision maker. And that's what people who make practical policy and give practical policy advice are always doing. And I want to stress that at this point especially, but at all points during this process, there are ethical issues involved. There are issues of professional ethics. One should not misrepresent things. One should not lie, in other words. One should not distort. And if there is some distortion going on, especially at the final stage of communication, the policy analyst should be honest enough and smart enough to know what it is and to inform the policymaker where the discrepancies are. So this aspect, I think, is also very crucial to understand. So once it gets to the decision maker, which may be a group rather than just a person too, and policy is made, then of course it will have an impact on the system, and it will change at least some part of the system. And depending on how complex the system is, a small initial impact in a complex system might actually become magnified a great deal. But in a simple linear system, it would be quite predictable. And then you can begin this whole process again. So it's an iterative process. It goes on and on and on. OK. Now some conceptual issues. We already have talked about theory and models, but we have a further step about identification and aggregation. We have to identify the model in a way that we can then be able to specify the parameters and use the data to estimate those parameters. But aggregation is also necessary. But it's a good question whether you start with aggregation and then disaggregate, or you have disaggregated data and then you aggregate, and if so, at what level? Again, these are abstract questions at this level, but whenever you have concrete problems, and I will show some of them, you can have fairly precise answers to these questions. And then, of course, you need to know the relevant data and estimation techniques. Now, to go a little further about policymaking, scientifically, of course, people have been thinking about these things for quite a while. I mentioned at one point political arithmetic tradition of the 17th century, which predates Adam Smith. But those were not so systematized. Tinbergen really was the first prominent economist and econometrician who asked the question, how do we really match instruments and targets? You know, once you have identified what the relevant questions are, and you have formulated a model, you have identified the targets. For example, if you want to reduce poverty by, say, 10% within the next 2 years, that's the target. Well, what instruments should you be using? That would be the next question. Well, Tinbergen posed the problem at a very general level. He says in one of his crucial papers that suppose we have n targets. How many instruments do we need to reach these n targets? And his answer is that if these n targets are all independent, then we should have at least n instruments to reach these n targets, and the instruments should also be independent. So one example of that is, say, if you want to reach the target of maintaining a certain level of unemployment, say your unemployment rate should be 4%, which is something that people kind of roughly and vaguely agreed on after the Second World War when Tinbergen was working. And another target should be stable price. Let's say you want to keep the inflation rate not as low as possible, but say at between 5 and 10%. Then what kind of instruments should we be using? Well, you can see that we have fiscal policy, we have monetary policy, And we can use them for both the purposes, perhaps fiscal policy for unemployment target and monetary policy for the inflation target. And it's a tricky issue, but we do have fairly decent theory to address this issue as to how much of each instrument we should be using. In other words, what combination of fiscal and monetary policy we should be using. Tinbergen won a Nobel Prize for this work, this pioneering work. Then Mandel took it a step further. Mandel also won the Nobel Prize for this work, among other things. Mandel said, well, let's think of a global economy or globalized economy where the national economy is connected with the rest of the world. Then we have a problem of internal balance, which is to maintain full employment, what we call full employment, and an external target, which is to maintain external balance in the balance of payments. How can we do this if we don't have, say, devaluation as a tool for us? And he showed very cleverly that if capital is somewhat mobile, then you could use monetary policy for the external target and fiscal policy for the internal target. And this is called his assignment principle. And this is a very clever piece of work. And you can follow it quite easily in one of his articles where he uses just a graphical exposition for this. Of course, to prove it rigorously, you need an algebraic model. OK. Now, in the 70s, we had rational expectations revolution, so-called. And the idea was that if agents expect rationally certain things, then they would take actions which would basically nullify that policy. So it was basically a do-nothing kind of policy advice. But that really means that the market left to itself works smoothly and without friction, something that we know not to be true. So this is, of course, a very controversial issue and has generated quite a bit of debate. But at the end of it, it remains an empirical issue. And the two basic issues are this. One, empirically, how much people's behaviors change when they expect certain things, and in what way do they change, and how quickly. And this is